All right, so we're on 3D.3 complex number plane. Okay, again, this is a suggested organization for your notes is to divide it into quarters. So to divide your notes into quarters. And box one, what we're going to do is we're going to go over some vocabulary. You are not going to have time to write everything that's there. Does that make sense? So we're going to work on paraphrasing. And if you feel like you need to come back to it, then you can come back to the notes or to the video to write down exactly what was there. Make sense? Okay. So we're in our first box, which is going to be our vocabulary box. So if you look in here, we have complex number vocabulary. So what we're talking about is a complex number plane, and complex numbers are made up of imaginaries. Your imaginary is this I. I equals the square root of -1. So when you see a number that says 5i, what that means is that you have 5 square root of -1, which meant that this used to be the square root of 25, -25. Which means that this used to be the square root of -25. It only allowed you to take the square root of 25, even though it's negative, because normally we're like, oh, we can't take the square root. It's a negative number. No solution. I'm done. And some really bored mathematicians like, no, those are called imaginaries. And we continue and we fight strong with them. Okay, so how does this work in terms of graphing them? Complex number planes are still on an XY plane. So they're still going to be on an XY plane. So you still have this guy. Ooh, that's a pretty straight line. Y'all see it? I know you see it. Okay. The only difference here is that your x-axis, that is your real axis. So that's what we're going to call, this is where your A value is. If A is positive, you go to the right. If A is negative, you're going to the left. Okay. Your y-axis is going to be your B. If B is positive, you're going up. If B is negative, then you're going down. So that is how you plot. So again, the horizontal, that's going to be your horizontal axis is for the real. The vertical axis is for the imaginary, which is why I labeled them as A and B. So it's not X's and Y's, it's A's and B's on a complex plane. Okay, the next thing is to be able to find the absolute value of a complex number. When you're looking for the absolute value, it's just simply the distance. Bless you, bless you. So if it asks you for the absolute value of a complex number, you're just finding the distance. And we're using the distance formula, which would be the square root of a squared plus b squared, or it's also the Pythagorean theorem. A squared plus b squared equals your radius, or equals your distance. Okay, are you ready to dive in? See how simple it is? All right, let's dive in. So in box 2, you're going to write the problem, the example, -5 plus 3i, but you're also going to draw a coordinate grid. Okay, the steps to graph are to identify what's your real and what's your imaginary. Remember that your real is on the horizontal axis and your imaginary is on your vertical axis. Notice I did not call them X and Y. I call them horizontal and vertical. So step 1 is to identify your pieces. So your A in this case would be what? What's your real? -5. It is the number without I. What's your imaginary? 3 is the number with I. Okay, step 2 is to graph. So step 2, you're going to go A, and A is negative. So I'm going to go to the left. 1, 2, 3, 4, 5. And then I'm going to go up. And I'm going to go up 3 because my B is positive. And boom, here's the point. This is where -5, 3i is. Ta-da! You can plot complex numbers. Was that terrible? Okay, step 3, it's asking you to find the absolute value. When it's asking you to find the absolute value, so it's telling you to find the absolute value of -5 plus 3i. That literally means to find the distance to 0. And what do you notice we made? A right triangle. Oh my gosh. And how do you find the distance of a right triangle? The hypotenuse. A squared plus b squared equals c squared. So do you see the correlation here? Okay. So to find our absolute value here, we're simply doing the square root of our a, which was -5, our b, which was 3, and we're adding and taking the square root because we're essentially looking for the hypotenuse. Are you with me? So we have -5 squared plus 3 squared. That's going to give us 25 plus 9. And what's 25 plus 9? 34. That would be our absolute value. Ta-da! So as you can see, we're learning something that's called complex, but has it really been complex? No, not at all. All right. Box 3. Guess whose turn it is? It's your group's turn. So in box 3, you're going to go through the steps. Identify your A, your B. Step 1. Step 2 is the plot. Step 3, calculate the absolute value. This one should take you approximately 60 seconds or less. Go. I said 60 seconds. That's not 6 seconds. Let's talk about her. Okay, so step 1 is to identify your real and your imaginary. What's your real here? 0. Good job. And what was your imaginary? 6. So when we come over here to step 2 to graph it, you're going to go to 0 and you're just doing what? Going up. 1, 2, 3, 4, 5, 6. So therefore, step 3, finding the absolute value of this. So finding the absolute value of 6i, that just equaled the square root of 0 squared plus 6 squared, which is just what? 6. You should have gotten 6. Yay? All right, let's try another one. Here you go. So your last box, you have example 3, 5 minus I.